Now, to find all the solutions to a linear inequality, one powerful way of doing that is to graph the solutions. So we actually graph the solutions as if we were graphing the line. Let's take a look at an example and see how to find all the solutions to a linear inequality. Let's consider y greater than x minus 2. All right, how do I graph that? Well, the first thing I do is realize that what's really going on here is I'm going to cut the world up, the plane up, into two pieces. Okay? And the boundary between one piece and the other piece is going to be the straight line given by y, and then putting an equal sign in here, y equals x minus 2. Okay, so the first thing we do is consider what's called the boundary line, which is the equation that you get by putting an equal sign in here. So imagine y equals x minus 2. What's the graph of that? Well, we know how to do that. The y-intercept is negative 2, right here. And the slope is an invisible 1 over 1. 1 up, 1 over. 1 up, 1 over. 1 up, 1 over, and so forth. Now, I want to connect them, but be careful. I'm not going to want to connect them with a solid line because actually, when I go back to the original question at hand, I see that this is a strict inequality. It's not y is greater than or equal to, with a little line underneath the inequality. It's y is strictly greater than this, which means that that boundary line will not be included in our collection of solutions, because that would be where y equals this, and y has to be strictly larger. So to indicate that, when we see a strict inequality here, we use the dash line. So we put dashes instead of a solid line. We'll use a solid line when the inequality is greater than or equal to, but here we use a dash line. Now notice that just as I advertised, we cut the world up into two pieces, this piece and that piece. Now how are we going to find out which one is the solution? One of them will be, and the easiest way to do it is to pick a point in one of the regions and then ask, is that point a point that satisfies the original inequality? If it does, then we want to be on that side. If it doesn't, then we want to be on the opposite side. So the point I usually pick whenever I can is the origin. So as long as my boundary line doesn't pass through the origin, it's a really easy point to pick. So let's pick x equals 0, y equals 0, and see if it satisfies this inequality. 0, is 0 greater than 0 minus 2? So is 0 greater than negative 2? It sure is, which means that this is the region that I want for my solution. And so this is the region that I'm going to shade in. And you can have really a lot of fun shading these in. When I was in school, my teacher called these hash marks, because it's sort of like hash kind of things. And so this is now the solution. So what does this mean? It means that any single point you pick in the coordinate plane that's in this orange region, but not on this dotted boundary, any point there will actually satisfy this. So you can see there's a half a plane worth of solutions to this linear inequality. Cool. Let's try another one together.